For our final project in chemistry this year, me and Amaya decided to do the can crusher demo experiment. This is where you take an empty can of soda or any sort of drink, whatever it may be, and basically you heat it up, you dump it in water, and it crushes just like this. So to get started with this can crusher demo, we're going to need a few materials first. We're going to need a ring stand and a platform. This is for putting the can on top of. We're going to need a Bunsen burner, a lighter for the Bunsen burner, a graduated cylinder, a large jar like the one being shown, and a pair of tongs. The first step in this experiment is to take the large jar and fill it all the way up with water and a lot of ice. The more ice, the better. It really doesn't matter as long as you have a cold jar of water, but basically the colder the water, the more your can is going to collapse. While that's being done or after that's finished, the next step is to set up the ring stand. You want to put the ring in a spot where you can definitely fit the can under it, but you don't want too much space in between the top of the can and the ring. This is because we want to get the water inside of the can boiling as fast as possible, and putting the can closer to the flame will get us to do that. Now obviously we're going to need a platform to put the can on, so we're just going to put that on right here. And then the graduated cylinder, where this comes in, is we're going to fill this up with 15 milliliters of water. This is a really good target volume. It doesn't need to be exactly 15 milliliters. We did try it with more than 15 milliliters and the effects weren't as good as the ones that we got in the end with 15 milliliters. So 15 is really the satisfactory amount to roll with here. After you measure out around 15 milliliters of water into that graduated cylinder, you're going to pour that water into the can so you have water to boil for the experiment. After that, you're going to place the can onto the platform. Now this is where the gas comes in. So now you're going to hook up the Bunsen burner to the gas. You're going to make sure the gas nozzle is turned so it's on, make sure the gas is running in the room, and then use the lighter to make the flame that you're going to boil the water with. As soon as that flame gets up and running, you're now ready to go. You can place the Bunsen burner under the can, and you're just going to wait. Depending on how much water you have in there and how close the burner is to the can, after a little bit you're going to see water vapor emerging out of the can. The water vapor might be a little bit inconsistent at first in terms of coming out, but after a little while, once it gets going, you're going to see that vapor constantly flow out of the can. And after you see it start flowing out like that, you're going to wait about 30 seconds with this water vapor coming out. This is just so we can get more air pushed out of the can, causing a greater pressure differential from the pressure outside of the can to the pressure inside of the can. Once your 30 seconds have gone by, you pick up the tongs, carefully pick up the can off of the platform, and make sure you lose as little water as possible as you turn that can over upside down and dump it into the ice cold water.
Yeah.
As you can see, this can collapse pretty good. The reason why this phenomenon happens is because of the fact that the pressure outside of the can, as I alluded to earlier, is constantly becoming greater than the pressure inside of the can, which is decreasing as you see water vapor coming out of that can. The more water vapor coming out of the can, the bigger of a can collapse you should anticipate. Because this can collapsing experiment is a demo associated with the gas laws branch of chemistry, we inserted a pretty straightforward gas law sample problem. The pressure on the inside of our can here is measured out to be 1 atmospheric pressure at 278 Kelvin. If the temperature is heated up to 312 Kelvin, what's the pressure on the inside of the can now? Since temperature and pressure are directly proportional, we use the formula P1 over T1 equals P2 over T2. When we input the values into here, we get 1 over 278 equals X over 312. We then multiply the 312 by both sides, and we get a much simpler looking problem that looks like this, and that adds up to 1.12 atmospheric pressure. That's going to wrap up the can crushing experiment.